Okay, time to talk about rectangles now. So Unit 5, video number 3. Let's get started. Okay, we're going to do the same thing we did with the parallelograms on the last video. We're going to put all of our marks on our rectangle here. Okay, so first thing that we know is that it's a quadrilateral, so that means it has 4 sides. It's a 4-sided polygon. And we know that both pairs of opposite sides are congruent and parallel. So this length is congruent to this length. This one is congruent to this one. And this is parallel to this. And this side is parallel to this side. So just like before, we need to label all of that. So both sides are congruent. We can go like this. Okay. And then we know that both sides are parallel, so we need to put the arrows that show that those two sides are parallel, and these two sides are parallel. So they're never going to touch, just like the parallelogram. Okay, well, the difference between the parallelogram and the rectangle is that with the rectangle, all 4 angles are right angles. Okay, that doesn't have to be true for a parallelogram. So let's go ahead and put those marks. So we need to show that all 4 angles are right angles, so that means that they're 90 degrees. So let's go ahead and draw those in. Okay, and then the last thing is talking about that a rectangle has congruent bisecting diagonals. So let's draw the diagonals and then we'll label them with that information. So here's our diagonal, and here's our other diagonal. Okay, so we know that the diagonals are congruent, which means that the 2 diagonals are the same length. So that means that they're the same length. The entire diagonal is the same. Okay, and it also means that they have been bisected, which means that they're all the same. So it was bisected, which means it cut it in half whenever they intersected. So that would make them congruent. It would make this length the same as this length, and this length the same as this length. Okay, so that's everything we need to label for the rectangle. Now let's try to find some missing sides and angles. All right, be sure to write down your title, properties of rectangles, and let's look at what we have to find. We're given rectangle ABCD. We have to find angle ACD. So we're going to try to find this angle right here. So let me go ahead and put a question mark right there. So we know that's the one we have to find. And let's put a spot for our answer. We're trying to find the measure of angle ACD. Okay, well, what's important to note is that we're working with a rectangle. So with a rectangle, we know that all of the angles are right angles. So all of these are right angles. So that means that this one up here is 90 degrees. They all are. So what would this angle right here have to be? If this one is 31, can we get this one? Well, we would have to take 90 and subtract 31 from it, which gives us 59. So this angle is 59 degrees. Okay, so there's a few different ways you could actually get the angle that we want. You could look at this triangle. You have a 31-degree angle, a 90-degree angle, and then your missing angle. Well, we know that all 3 of those, because it's a triangle, have to total 180. That's one way. Or think back to the problems we did with parallelograms and remember that this angle was the same as this angle, and this angle is the same as this angle. So you can do it that way. It's a little bit faster. So we know that our missing angle would have to be 59 degrees. But let's say you forgot that and you just remember that all angles of a triangle add up to 180. Okay, well, you could set up your equation. 31 plus 90 plus the one we don't know equals 180. So you'd be looking at this triangle right here. And you would just have to solve this. So we would get x plus 121 equals 180. Subtract 121, and that gives us 59. So either way works. All right, take a look at number 2. This is going to be our last problem for rectangles. So we have rectangle A, B, C, and D. And we know this length. Actually, we just know this length. And we just know this length. And we need to find BD. We want to know the whole length. So what we could do is remember that the diagonals are congruent bisectors, which means that they are congruent in this way. Okay, so that tells us that this length has to be the same as this length, and this length has to be the same as this length. So, and also, this length has to be the same as this length. So, why don't we go ahead and use what we have? We know that this is congruent to this. So let's set that equation up. First off, let me put a spot for my answer. BD equals. Okay, so let's set up our equation. 4x plus 9 equals 6x minus 7. We know that they're congruent because of the properties of rectangles. So we solve. Let's get our 4x to the other side. So 9 equals 2x minus 7. Add 7 to both sides. 2x equals 16, which means that x has to equal 8. Well, our answer is not 8. X is 8. So we have to plug x in, and we'll get this length right here. So let's plug it in. 6 times 8 minus 7. That's 48 minus 7, which is 41. So this length right here is 41. We want this entire length. We want BD. Well, because they're congruent, we know that this is also 41. So BD would have to be 41 plus 41, which equals 82. So the length of BD would be 82 units, whatever it is that we're working with, feet, inches, centimeters, we don't know. Okay, so really important that you know the property that these diagonals are congruent. These are congruent. All 4 of these lengths are also congruent. Okay, so keep that in mind. Okay, well, smile. I hope you have a good day. See you in class.